to admit something about my job. For years, I helped manage a water crisis in São Paulo that nearly emptied a reservoir serving 20 million people, treating it the entire time as a local engineering problem, bad rainfall, aging pipes, a system that needed better infrastructure and better forecasting. I work in water supply planning for the utility that serves the city, and my entire professional instinct runs toward the local and the fixable. If the taps are running dry, you look at your own reservoirs, your own pumping stations, your own leak rates, and you solve the problem inside the boundary of the system you actually control. I've built a career, over many years now, on believing that boundary is where the real, actual work happens, and I've defended that belief in front of city councils, journalists, and, more than once, genuinely frightened residents who wanted a simple explanation for why their water had stopped running the way it always had before. Then a scientist named Camila called me about a forest. Dr. Camila Rocha studies atmospheric hydrology at a research institute in Manaus. And we met years earlier at a conference where she'd presented data that I remember finding interesting in an abstract, slightly disconnected way, the kind of finding you nod along to without feeling it applied to your own work. She called on a weekday afternoon, mid-morning for her, her voice carrying the specific energy of someone who has been waiting for the right moment to make a point she's clearly made before, and asked if I could come to Manaus to see, in person, the actual mechanism behind a drought I'd spent 2 years of my career treating as a local São Paulo problem. I asked her, a little defensively, what a forest 2,000 kilometers away could possibly have to do with a reservoir I'd personally helped manage through its lowest point in recorded history. The specific low point that still occasionally shows up in my dreams as a number on a dashboard rather than an actual memory. She told me, simply, that she wanted to show me a river most people never think to look for, because it doesn't flow across the ground. It flows through the sky, and my city had been drinking from it for longer than anyone in my department had ever acknowledged. I laughed, I think a little too loudly for a work call, and told her that sounded like the kind of thing a conference speaker says for effect. She didn't laugh back, she just told me to bring good boots. Flight 2 weeks later. I told my supervisor I was attending a research conference, which was technically true, and left out how personally unsettled I already felt about a version of the crisis I thought I understood completely. On the long flight north, I found myself pulling up the internal reports I'd helped write during the crisis, rereading our own explanations for the reservoir's collapse, inadequate storage capacity, delayed infrastructure investment, an unusually dry, rainy season we'd treated as simple bad luck rather than a symptom of anything larger. Not one of those reports, I realized somewhere over the Brazilian interior, mentioned a forest. In 2014, the Cantareira reservoir system that supplies a large share of São Paulo's water dropped so low that the utility had to pump from what engineers call the strategic reserve, water sitting below the normal outflow pipes, essentially the mud at the bottom of the system. I'd helped run that pumping operation. I'd stood in front of public meetings defending our infrastructure choices while frightened residents asked why their taps were failing. I had never once, in any of those meetings, mentioned a forest. Manaus meets you as a genuinely strange contradiction. A modern city of over 2 million people sitting in the middle of a rainforest that stretches for thousands of kilometers in every direction. Reachable by very few roads and, for most of its history, essentially none at all. The city's original wealth came from the rubber boom of the late 19th century, when Manaus briefly became one of the richest cities in South America, its elite importing European architects, Italian marble, and French ironwork across more than 7,000 kilometers of ocean and jungle to build the Teatro Amazonas, an opera house so ornate it still looks faintly absurd against the surrounding tree line. A monument to money that had traveled further than almost any other building material in the world to reach a place with, at the time, no roads connecting it to anywhere else. Camila mentioned walking me past its facade that first evening, that singers performing there in the boom years reportedly complained about the humidity warping their voices, a small, human detail that made the whole extravagant project feel less like a myth and more like a genuinely strange, specific decision real people had made and then had to live inside. Camila met me at the airport and, instead of taking me straight to her research station, drove me first to the edge of the city where the Rio Negro and the Solimões meet, a phenomenon known locally as the meeting of waters. For nearly 6 kilometers, the two rivers run side by side without fully blending. The Negro's dark, tea-colored, acidic water pressed directly against the Solimões' lighter, sediment-heavy current, a visible boundary drawn straight into the river by nothing more than differences in temperature, density, and speed. Early explorers wrote pages trying to explain it. Modern scientists still use the exact spot as a natural laboratory for studying how differently structured bodies of water interact before they're finally forced to merge downstream into the river. Most of the world simply calls the Amazon. Standing at the rail of Camila's small research boat, watching that clean, physically improbable line hold for kilometers before finally dissolving, I understood, in a small way, what she'd actually flown me out to learn, that some of the most consequential boundaries in this system are invisible right up until you know exactly where to look for them. That evening, over dinner at her research station, Camila finally walked me through the science she'd been building towards since her first phone call. The Amazon doesn't just receive rainfall, she told me, it generates a meaningful share of its own. Each tree releases water vapor into the atmosphere through transpiration. A single large tree capable of releasing more than 1,000 liters a day, and multiplied across hundreds of billions of trees, that moisture rises into what researchers call flying rivers vast. Continuous corridors of atmospheric moisture moving through the sky above the forest, some of them carrying more water than the Amazon River itself carries on the ground below. A square meter of dense canopy, she told me, can hold the equivalent surface area of 8 or 10 square meters of leaves, once every layer is accounted for, which means the forest evaporates moisture at several times the rate open ocean water does across the same footprint. These atmospheric rivers don't stay over the forest. Prevailing wind patterns push them south and west, across the continent, delivering rainfall to agricultural regions, major cities, and entire river basins thousands of kilometers from the nearest standing tree. She pulled up a set of research findings I hadn't previously encountered directly, despite having spent 2 years professionally immersed in exactly the crisis they explained. Findings I probably should have gone looking for myself far earlier than a friend having to fly me across a continent to see them in person. Multiple independent research groups, including work out of the University of São Paulo, now estimate that Amazon deforestation accounts for a substantial share of the dry season rainfall decline across central and southern Brazil, some analyses attributing more than 70% of the reduction directly to the weakening of this atmospheric moisture transport. A researcher named Antonio Nobre had been warning as early as 2009 that continued deforestation would eventually produce exactly the kind of catastrophic regional drought that hit São Paulo 5 years later, a warning that had circulated mostly within academic and environmental circles at the time, well outside the world of utility engineers like me. Camila didn't present this as a settled, uncontested fact. The science of attributing any single drought to a specific cause remains genuinely difficult. She was careful to say, and she pushed back gently when I tried to compress it into a cleaner story than the data actually supported. But the mechanism itself, moisture generated by the forest traveling south to feed rainfall my own city depended on, was no longer a hypothesis. It was measured, tracked, and increasingly treated as a foundational fact of South American climatology, even if the exact contribution of any single drought remained an active research question. I was wrong about something specific, sitting in that research station. I'd spent 2 years defending my utilities infrastructure choices, as though the crisis had been, fundamentally, a local failure of planning and maintenance, a failure I could trace, explain, and eventually correct within the boundaries of systems I actually controlled. What Camila was describing was a crisis whose actual root cause sat entirely outside any boundary I'd ever been trained to consider part of my job, in a forest I had never once, in 2 years of crisis management, thought to mention in a single planning document. My city's water security, it turned out, had depended the entire time on the health of a forest most of my colleagues had never seen and rarely discussed. The next morning, before we went out on the water again, Camila took me to see something underground, a research plot maintained by archaeologists studying terra preta, dark, engineered soil found in patches scattered across the Amazon basin. These soils weren't formed naturally. Pre-Columbian societies, working more than 2,000 years ago, deliberately mixed charcoal, food waste, ash, and organic material into the naturally poor Amazonian ground, creating patches of unusually fertile, dark earth that, remarkably, still regenerate their own fertility today, supporting plant growth far beyond what the surrounding, unmodified soil can sustain. A researcher working the site that morning let me hold a sample from each side of the boundary, the terra preta crumbling, dark and rich between my fingers, the unmodified soil beside it pale, dense, and noticeably poorer in organic content, the difference obvious even to someone with no training in soil science at all. Camila told me researchers still don't fully understand every mechanism keeping terra preta self-renewing centuries after the societies that created it disappeared, but that it stands as one of the clearest examples anywhere on Earth of a human civilization, engineering a landscape to outlast itself by millennia, without machinery, without written records surviving to explain the technique, simply through generations of accumulated, transmitted practice. Standing at the edge of that dark earth plot, holding a handful of soil noticeably different in texture and color from the ground a few meters away, I thought about how much of what I'd seen in the previous 24 hours kept returning to the same underlying idea from different angles. Systems whose real mechanism operates far outside the boundary most casual. Observers, including professional ones like me, ever think to examine. A river with no visible channel, moving moisture instead of water, a patch of unusually dark dirt, quietly outperforming millennia of unmodified ground. My own city's drought, whose actual cause sat in a forest most of the people who lived through the crisis with me never once considered relevant to their own taps running dry. Before the Anavilhanas run, Camila wanted me to see one more example of how completely river-dependent life gets across the basin, so we took a short flight into Peru, to Iquitos, one of the largest cities on Earth with no road connection to anywhere else. The city's own rapid rise traces back to the same rubber boom that built Manaus. Wealthy traders importing European architecture and furniture into a genuinely remote settlement almost overnight, only for the entire economy to collapse just as quickly once the rubber industry moved elsewhere. What survived that collapse was a city that had already learned, out of necessity, to run entirely on its river's boats, functioning as taxis, buses, and delivery trucks, seasonal flooding, raising water levels by several meters, and forcing homes and markets to adjust their entire physical layout year after year. Further into the interior, we passed briefly through the edge of the Pacaya-Samiria Reserve, more than 20,000 square kilometers of protected wetland that locals call the Mirrored Forest, because during the wet season entire sections of canopy stand reflected so precisely in the floodwater beneath them that the boundary between tree and reflection nearly disappears. Fish move directly into the flooded groves to feed. Pink river dolphins use the same submerged channels to reach new hunting grounds. And the paths that exist during the dry months vanish completely once the rains return, forcing communities inside the reserve to relearn their own travel routes twice a year. Camila told me researchers use the reserve as something close to a living benchmark for understanding how flooded ecosystems respond to a changing climate. Precisely because its cycles are so extreme and so well documented that even small shifts in timing or intensity show up clearly against decades of prior seasonal data. The night everything actually came into sharp focus for me happened a few days later, when Camila arranged for me to join a supply run through the Anavilhanas archipelago, a freshwater labyrinth stretching more than 380 kilometers along the Rio Negro, thousands of islands and channels that shift shape continuously as sediment builds and erodes with the river's seasonal pulse. Our captain that night was a man named Ronaldo, who has navigated this stretch of river for 16 years, carrying medical supplies, fuel, and mail to communities scattered through the archipelago that have no other reliable access. He grew up on one of the river's larger islands, he told me while we loaded the boat, and had been running these channels in one capacity or another since he was a teenager helping his father on the same route. We left after dark, specifically because a shipment of medication needed to reach a remote clinic before morning, a delivery timeline that didn't leave room to simply wait for daylight. Ronaldo ran the boat mostly by memory and instinct rather than instrument, a skill Camila told me was common among captains who'd worked these channels long enough, reading subtle shifts in current, sound, and watercolor that no chart could fully capture, since the charts themselves went out of date within a season or two as the islands reshaped themselves. About an hour into the run, Ronaldo slowed the engine to a near crawl, something in the channel ahead reading wrong against 16 years of accumulated memory. He'd taken this exact route dozens of times, he told us afterward, and the water in front of us that night simply didn't match what his own mental map of the river insisted should be there, a sandbar, invisible, in the dark, that shouldn't have existed yet based on everything he'd learned about how this particular stretch of channel normally shifted. He had a decision in front of him with no comfortable version. Trust the old route, the one his memory and years of experience told him should still be correct, and risk running the boat aground on a sandbar that may have formed more recently than his mental map accounted for, or trust the subtle, hard-to-articulate sense that something ahead had changed and shift to an alternate channel he knew less intimately, one that carried its own unknown risks, precisely because he'd navigated it far less often. Either choice risked delaying medication a clinic full of people were waiting for. Either choice, if wrong in the specific way that mattered, risked damaging the boat badly enough to strand all of us in the dark, hours from help. Camila told me later that she'd seen captains freeze in exactly this moment before, caught between two imperfect options for long enough that the delay itself became the actual danger. I watched him work through it in something close to real time, cutting the engine further, using a long pole to test depth in the dark, rather than relying purely on memory or instrument, moving the boat forward in careful increments, while Camila held a light low over the water, both of them reading a river that refused to hold still long enough to be fully known by anyone, no matter how many years they'd spent trying. Ronaldo chose, in the end, to shift to the alternate channel, adding perhaps 20 minutes to the run, working the unfamiliar route slowly and carefully, rather than trusting a memory he no longer fully believed. We reached the clinic a little after 4 in the morning. The medication arrived in time. Nobody I spoke to afterward treated the detour as a dramatic story worth retelling for Ronaldo. It was simply what the job actually requires, on a river that never stops quietly rewriting itself underneath the people who depend on knowing it. A nurse at the clinic, unloading the boxes we'd carried, thanked him the same unremarkable way she probably thanked him every other week, with no sense that anything unusual had happened getting the shipment there. I was wrong about something specific, watching that unfold. I'd assumed, walking onto that boat, that 16 years of experience on a single stretch of river would function essentially like a fixed, reliable, map-accumulated knowledge that, once acquired, simply kept working indefinitely. What I actually watched was a man treating his own hard-won expertise as provisional, something requiring active, ongoing revision rather than passive trust, because the river itself had never once agreed to stay still long enough to reward blind confidence. Ronaldo told me over coffee the next morning that the channels shift enough every single season, that captains who stop actively questioning their own memory eventually run aground not because they were careless, but because they mistook years of accurate memory for a guarantee the river had never actually offered. He said it without any particular drama, the way a person describes a fact about weather rather than a lesson learned the hard way, though I suspected, from the specific way Camila glanced at him when he said it, that there was probably a harder version of that story somewhere in his own past that he simply wasn't planning to tell a visitor he'd just met. Once that night's tension had settled, Camila had several more days planned before my flight home, and she used them, deliberately, to show me how far this same underlying pattern systems whose true mechanism operates invisibly, far outside where most people think to look extended across the rest of the basin, we flew south to Alter du Chão on the Tapajós River, where brilliant white sand beaches appear only during the dry season as the river drops by several meters, exposing sandbanks that stay submerged the rest of the year. The Tapajós carries far less sediment than the darker Amazon tributaries, allowing sunlight to penetrate deep enough to produce a genuinely startling turquoise clarity, closer in color to a coastline than anything I'd expected from a river this far inland. We arrived during the transition between seasons, the beaches only partially exposed, sandbars emerging at the edges of water that would, in another month, cover them completely. When the water rises again, the beaches vanish entirely, and entire groves of trees along the banks become submerged habitats where fish feed directly on fruit and seeds falling from branches that, months earlier, stood well above any waterline. Camila pointed out that local festival calendars, fishing patterns, and transportation routes all reorganize themselves completely around this single seasonal shift. An entire regional rhythm built around water that spends half the year in a completely different physical configuration. Residents adjusting without much apparent friction to a landscape that essentially redraws its own map twice annually. We continued into Peru a few days later, to the Tambopata region, where wide riverbanks known locally as calpas draw dozens, sometimes hundreds, of brightly colored macaws at dawn to feed on mineral-rich clay. Researchers believe the minerals help the birds neutralize toxins present in the seeds and unripe fruit that make up much of their diet, allowing them to safely process food that would otherwise be harmful. We arrived before sunrise, sitting in near silence in a blind positioned across the river from the clay wall, watching the birds gather cautiously at first, small groups testing the air before committing, then finally descending in a sudden wave of color and noise loud enough that I felt it as much as heard it. What struck me most, watching a wall of clay erupt into red, blue, and green movement as the birds arrived in tightly coordinated waves, was how specific the behavior actually is. Not every riverbank works, only sites with precisely the right mineral composition. And the same birds return to the same exposed clay walls repeatedly, sometimes traveling significant distances past other, seemingly identical stretches of riverbank that simply don't contain what they need. A researcher working nearby told me the timing of the feeding activity tracks fruiting cycles closely enough that watching the clay licks alone can tell you, with reasonable accuracy, what stage of the season the surrounding forest has entered, an entire calendar written in bird behavior rather than dates. Near the end of the trip, we flew to the Venezuelan side of the basin, to Canaima National Park, dominated by massive sandstone plateaus called tepuis, rising abruptly from the surrounding lowland, some reaching well over 2,000 meters, isolated, long enough nearly 2 billion years in some cases, that scientists describe their summits as functioning almost like separate evolutionary islands, home to species found nowhere else on the planet. Angel Falls drops nearly 1,000 meters from the edge of Auyan Tepui, the tallest uninterrupted waterfall on Earth, the water dispersing into drifting mist long before it ever reaches the pool below, the falls themselves visible from a distance as less a single stream than a slow-motion cloud sliding down the cliff face. We approached by boat and on foot over 2 days, the falls staying visible for hours before we actually reached the base, growing from a thin white thread against the rock into something loud enough to feel through the ground. Indigenous Pemon communities have lived among these plateaus for generations, maintaining detailed traditional knowledge of the region's geology and weather patterns that long predates any formal scientific survey of the Tepui's extraordinary age. A guide from one of those communities pointing out weather signs in the cloud cover around the summit that meant nothing to me and clearly meant a great deal to him. On my last full day in the basin, we crossed into Colombia to see Caño Cristales, a river whose vivid reds, yellows, greens, and purples come entirely from a single aquatic plant, Macarinia clavigera, that only displays its full color under a narrow, the specific combination of clear water, strong sunlight, and precisely balanced current speed. Too fast, and the plant detaches from the riverbed. Too slow, and sediment settles over it, muting the color entirely. Access to the river is now tightly restricted, footpaths and viewing platforms carefully controlled to avoid disturbing the exact flow conditions the entire spectacle depends on, guides limiting group sizes and steering visitors away from the most fragile stretches, even when the color there was, by a wide margin, the most striking of the entire river. Standing at the edge of that impossibly colored water, I thought about how the whole trip had essentially been one long demonstration of the same principle at wildly different scales. A spectacle, a forest, a city's water supply, all of them held together by a precise, easily disrupted balance that almost nobody standing directly in front of it ever fully sees. I flew home 2 days later. Camila stayed, obviously her research is there, in a way that made far more sense to me, having spent 2 weeks standing inside its actual subject matter than it ever had, reading her papers from a conference hallway in São Paulo. We talk more since the trip than we did before it, usually circling back, in one form or another, to some version of the same unresolved question neither of us has fully answered. How many of the systems I'm professionally responsible for actually depend on something outside the boundary I've been trained to examine, and how would I even know if nobody had ever specifically flown me out to see it? She emailed me about 6 weeks after I'd landed back in São Paulo with an update from Ronaldo. The channel he'd rerouted around that night had, by the next survey, confirmed exactly the kind of sediment shift his instinct had detected in the dark. A new sandbar that hadn't existed the previous season, now marked on the regional charts. The local captain's cooperative maintains and updates themselves, informally, faster than any official agency manages to. Camila told me the update had come from Ronaldo directly, logged the same week as the incident. A small, specific correction folded into a body of shared knowledge that the whole cooperative depends on staying current, one captain's revised memory at a time. She also mentioned, almost as a postscript, that she'd started sharing some of her flying river modeling data directly with a contact at my own utility back in São Paulo. A small, informal collaboration that hadn't existed before my visit and that neither of us had specifically planned, but that felt, to both of us, like the actual point of the trip finally landing somewhere useful. I don't think the lesson I took from that trip is really about rivers. Not only, it's about how easily my own professional training had drawn a boundary around what counted as my problem, treating anything outside that boundary as someone else's responsibility to track, when the actual systems I'm accountable for never respected that boundary in the first place. São Paulo's water crisis wasn't a local engineering failure with a local engineering solution waiting to be found if we'd just worked harder inside our own reservoirs. It was a symptom of a much larger system, most of it invisible, most of it operating thousands of kilometers outside anything my department had ever been asked to monitor. I've started, since coming home, quietly proposing that our planning reports include at least a section acknowledging the basin scale factors we have no direct control over, which has been met with exactly the mixture of interest and skepticism I probably deserve. For showing up with this particular epiphany 2 years after the crisis, it would have actually helped explain. What stays with me most isn't the scale of any single site. Honestly, not Angel Falls' height, not the age of the Tepuis, not even the specific volume of the Amazon's discharge into the Atlantic, a figure so large it's genuinely difficult to hold in your head as anything other than an abstraction. It's the image of Ronaldo testing depth with a pole in complete darkness, refusing to trust 16 years of memory without also actively questioning it, because the river he depended on had never once promised to stay the way he last remembered it. I think about how much of what actually keeps a system functioning, a river route or a city's water supply, depends on someone willing to keep rechecking a pattern they already believe they understand, rather than assuming yesterday's map is still accurate simply because it used to be. I think, too, about every planning document I've signed off on that treated last decade's rainfall data as a stable baseline rather than a snapshot of a system that was already, quietly, becoming something else. A short breath before I let you go. If this story changed how you think about where your own city's water actually comes from, I'd genuinely like to know which part of it stayed with you, because somewhere above the forest right now, an invisible river of moisture is moving south, feeding rainfall in places most of the people drinking that water will never think to trace back this far, in a cycle that has been running quietly, unnoticed by almost everyone it feeds, for longer than any city downstream of it has existed. How many of the systems we depend on every day are quietly connected to something thousands of kilometers outside the boundary we've been trained to call ours, waiting for someone to fly out and actually look? This narrative is told through the perspective of Diego Ferreira, a fictional water supply planner based in São Paulo, and includes the fictional composite characters Dr. Camila Rocha and Ronaldo. The scientific, historical, and geographic details of the Amazon basin described here, including the atmospheric moisture transport known as flying rivers, the documented link between Amazon deforestation and the 2014 to 2015 São Paulo water crisis, and the existence of terra preta soils are real and presented as accurately as possible at the time of writing. The specific overnight river navigation incident described in this script is a fictionalized composite, not a documented real event.